Okay, so Unit 1 is on digital image fundamentals. Let us just try to understand what we are going to study here. In fact, the topics that we are going to study is divided into two parts. As you can see, I have colored them differently. The first few classes will be discussing on, first of all, what is digital image processing, what are the fundamental steps, and the components that we use in an image processing system, a concept of sampling and quantization in images. And once we sample and quantize, we get pixels, and we will understand something more about pixels in terms of the relationship. Then how we can do connected component analysis. So this is one part of Unit 1. Second part, we will be discussing about image transforms. To start with, why do we need image transforms? And a special class of transforms called orthogonal and unitary transforms. Why this property is very important in image transforms, and some properties of these unitary transforms. And we discuss examples of these transforms starting with DFT, then DCT, Hadamard, HAR, then to end with KL transform. So as I already told you in the beginning of this course, we have 6 course outcomes. The first course outcome will be on Unit 1, which says students should be able to identify various steps and components in a digital image processing system at the end of this course. And also you should be in a position to analyze digital images both in spatial and transform domain. So with this brief introduction to the contents of the first unit, let us start with the definitions. Now, as you all know, in fact, I have discussed many applications during my presentation, the last few classes. So, there are basically two principal application areas that you can categorize. One is improvement for human interpretation. For example, the first application, satellite image processing or satellite uh, images restoration. We are interested in improving the interpretation of the image, maybe in terms of edges, maybe in terms of uh, maybe contrast or whatever it is. Just try to improve the quality of the image for better interpretation. Now the second application is you want to store the data, or you want to transmit the data, or you want to represent the data for maybe autonomous perception. For example, I want to recognize license plate of a vehicle. So I need to capture the image. It is not enough I improve the quality. It is not enough I do pre-processing. I should be in a position to recognize each and every character, then identify which vehicle it is. So these are the principal application areas of image processing, and I already had mentioned that image is a two-dimensional function. That means it has x and y as its uh, coordinates, and at every value x and y you will have some specific number which we call it as gray level. So x and y are called spatial coordinates, and f is called the gray level. Now, if all these three are finite and discrete, that means your f will have discrete values and it will have some finite values. Even x and y will have discrete values and finite values. Then we call such an image as digital image. All the three should be discrete, then we call it as a digital image. Let me just show you a MATLAB demonstration. Is the MATLAB window visible?
Yes, sir.
Okay.
Yes, sir.
See, please observe, because you have to do your lab from here onwards. So observe some commands that I am using. You can see here I am reading an image. Im read is the command to read an image, and I am showing it on the figure window. And just to start a new figure, we usually use the command figure. And I'm using another command here called impixelinfo, which actually gives you the information of the pixel at the position of the cursor. Let me just demonstrate this by just running only this part of the code. So you saw that I have read an image, it's a boat image. So I have read it and I am showing it. Now this pixel info, just keep observing as I move the cursor on the bottom corner of the image, you could see that the x value, y value and the uh, gray value is visible. 199 comma 270 is the x and y coordinates. 226 is the gray level. For example, you can see I'm just moving my cursor at the somewhere near the cloud position, and cloud, it is white in color, so you can see the gray value, it is around 200. Suppose if I move my cursor somewhere in the dark region here, this is a black region, so you can see the pixel value is around 28 or 30. Okay, maybe at this point it is still white, so you can observe that it is about 220 as a gray level. Okay, so what I just want to demonstrate with this demo is, as you can see, x and y are discrete and they are finite values, and also your gray level f is also discrete. I am not getting something like 220.2, 220.3, or I am not getting the pixel coordinates as 317 point something or 141.2. So it is discretized, both x and y, and also your f is discretized. So that is what I meant by digital image. Okay. So I think these type of simple image operations you can perform on MATLAB. MATLAB online is available. I hope you know about it. So online MATLAB means you don't need to download or install MATLAB on your systems. You can use your mobile itself. Now since we are meeting online, so let us not take it as an excuse that we cannot do the lab. I want you to continue doing the lab using your mobile phone itself, and if you have laptop and if you are connected to internet, I think you can use online MATLAB. So x, y are finite, and this is a digital image, and if I process such an image where x, y and f are finite, then I call it as digital image processing. So that is the definition. Processing of digital images by using a computer. And every element that you saw, each of them, whenever I move the cursor, we call that as a picture element or an image element or pixel or pel. Okay. So this is what we mean by digital image processing. Now, this is a very important, in fact, topic, because if this is understood clearly, whoever is developing an image processing system can easily formulate your problem and identify the steps that we use. Okay, so these are the fundamental steps. It doesn't mean that these are the only steps that are there in digital image processing. There are many. So some of the blocks, okay, you can add later also, but this is the steps that is given in Gonzalez new edition textbook. In fact, you can add some more steps here later. Anyway, so let us first understand each and every step, and then maybe I also give you a typical example. Okay. Um, so you have a problem in hand which has to be analyzed by using image processing. Let me just take the example of license plate recognition as a problem domain. So the job to you that is assigned to you as an image processing expertise, you need to uh, identify the license plate of license plate number of a vehicle from a video. So the problem domain is that input is a video which is captured at a particular position kept, okay, maybe in the entrance of probably the SIT main gate. So vehicles are entering in. So your job is to recognize the license plate number and decide whether it is a known vehicle or an unknown vehicle entering into the campus. This is a problem domain. So the first thing that I should do is I should acquire this image. So obviously, since I told input is a video, so you need to use a video camera here. So the acquisition device will be a video camera. So the decision that you have to take is what should be the resolution of the camera, what should be the position of the camera where I should keep it, and then record the video. Okay. Then after that, since I want images to process, probably within this block you should also have a pre-processing step where you can convert the frames, the video into frames. Then you need to have a standard size data, so you may have to resize the data and have it as a standard data. So image acquisition means it will have some pre-processing also. Now if the problem is something different, for example, if I want to recognize face of a person, face recognition, then my image acquisition device will be a camera. It could be a still camera also. Okay. If my requirement is I'll go stand in front of the camera, it will capture my face and I start recognizing it. Okay. Suppose if it is maybe some ultrasound images are to be taken, then your camera should be your ultrasound camera. If I want to take X-ray of some data and do some image processing, then this should be an X-ray imaging technique. So what I want to convey here is, depending on the problem domain, you decide the type of the camera that I have to use, the resolution, and maybe some pre-processing steps to bring it into a standard requirement. So this is one block in an image processing system. Okay, this is one of the step. Acquisition is important. Okay, then the captured data may not be good enough for you. For example, if it is a license plate image, I have captured it. The camera is kept in front of the main gate. Maybe it is somewhere in the evening. Um, so probably the contrast may not be good because there's a okay, the resolution is very bad, or maybe the what do I say? If for example the illumination is not that good, so I cannot work with such images directly because my license plate recognition system fails. So what I need to do is I need to enhance the image for my requirement. That means improve the image for my requirement. Maybe I have to make sure that illumination is uniform. That means you just okay, by using image processing, try to do some contrast variation so that the image looks okay, uniformly illuminated. The edges may not be that good, so you might have to improve the edge information because the recognition of the characters is also important. Then there could be probably some change probably in terms of the contrast, so I may have to do perform some operation so that it improves the data for my requirement. So image enhancement is actually a subjective method where the input image which might have some variations in illumination or contrast, or maybe the edge is not that good, I just improve this image so that I get a better quality image which can go to the next stage. So that's what is this block, image enhancement. Suppose if the image quality is good and it is good enough, your image processing system may not have this block. Okay. So, but usually image enhancement will be one of the pre-processing step that is normally used in most of the image processing techniques, methods. Another important requirement is image restoration. See, what happens is you cannot expect the vehicle entering into the main gate to stop there so that the image is captured nicely. The vehicle will be moving at its own speed. Camera is capturing at some frames per second, video camera. So obviously there is a relative motion because of which there could be some blur that happens. Second thing is it could be a rainy day where there could be some noise that gets added when you are capturing an image. So uh, the data that you have captured may not be good enough for doing the operation. So you may have to remove this blur or noise that gets added during the acquisition. So basically this particular in fact block performs that. It tries to restore the original quality of the image from a degraded version. That's what image restoration does. And definitely this is an objective process. Image enhancement is subjective, image restoration is objective. Okay. Um, in fact, in your syllabus, we don't discuss much about the image acquisition. We'll assume that the image is already acquired. We will discuss in fact, the second unit is about image enhancement, and the third unit is image restoration. Okay, so that is how the syllabus is covered. And some of these blocks are not there in your syllabus for this semester. So the next is color image processing. Uh, See, the next thing is, for example, um, uh, I just don't want to just recognize the license plate. I also want to know whether that is a public vehicle or a private vehicle. Sorry, maybe a government vehicle, or a if it is a rented vehicle, or an okay, in fact, a personal vehicle. All of you know that the license plate color differs for personal vehicles and maybe some rented vehicles. So I may have to use some color information to recognize that. Okay. So if that is the case, this block is also required in license plate recognition system. If somehow I am not interested in what type of vehicle it is, I only want to recognize the license plate region. This block may not be there for the requirement. But this would be required for some other application. For example, maybe face detection, face recognition. You want to recognize the face based on the color, the skin color. So obviously, I need some color image processing technique which recognizes the skin color and separates the face from the background. So I need color image processing. Okay. So what I just want to convey in this block is some of these blocks may be required, some may not be required for your requirement. In fact, if you go through some project reports carried out earlier, you will understand okay, how I can use this blocks to probably develop a block diagram. Okay, so color image processing basically does color processing. That means it may just try to recognize an object by using color. For example, you want to recognize, as I showed you the traffic signboard detection system. So definitely you can see the traffic signboards will have okay, the signboard printed, and there will be a red circle around it. So I may use that color information to recognize the color of the, in fact, to identify the traffic signboard. So this is what color image processing does, but we don't study about this in this course, and I think it's straightforward. The other one is wavelets and multi-resolution processing. See, wavelets basically it's okay, helpful in in fact, identifying the frequency contents of the data. For example, you can separate noise from the in fact, the original image by using wavelet transforms. Again, we don't discuss much about this. Of course, wavelets can also be used for compressing the data. So we don't study this in this course. Anyway, this is one another processing that may be required. Then compression, again, this we may not do it, but by the name compression, I need to reduce the data. There are many two methods, where one is lossy compression, where you allow some loss in the image, lossless compression, where you don't want to okay, lose any data. So compression is not a part of our syllabus, but it is going to reduce the data because when you want to transmit this images over a longer distances, the data has to be size has to be very small. So compression is a requirement. Then morphological processing, this you are going to study in the last unit actually. What it does is it tries to, in fact, okay, improve the features of an image. For example, there could be for example, a character recognition system. The character has to be completely written, then only you can recognize. So because of some problem while acquiring, if the character is not completely visible, you may have to fill this data by using some processing technique. So that filling operation, in fact, it is done by using this morphological processing technique. That means you make the data more, in fact, in fact, suitable for maybe the next block. That means to recognize the characters, you need to probably have all the edges very clearly visible. So if there is any missing data, I just try to fill it by using some processing. There are many operations called dilation, erosion, hole filling. We will discuss this in the end. So this will be done in morphological processing. We will discuss this in one chapter, one unit. Then segmentation, as the name itself says, you are trying to separate the foreground from the background. For example, in the example that I have given you, that is license plate recognition, as I also told you during my class, the first requirement is from the video you should segment a vehicle from the background, because that is the first requirement. The frame may have a vehicle or it may not have a vehicle. So first thing is you identify that frame which has a vehicle. So separating vehicle from the background or segmenting vehicle from the background. After I do that, I am not interested in the entire vehicle region. I am interested in only in the license plate region of the vehicle. So license plate has to be region has to be extracted from the background. So this is done by using segmentation techniques. Okay. So segmentation technique is a very crucial step in plate recognition system, face recognition system also. You want to first segment the face region from the background, then you can do some operations to recognize the face. This also we are going to discuss in our syllabus, and the next two we may not discuss, but still, okay, you representing and describing. For example, whether in a segmentation technique, once I get the okay foreground, am I interested only in the edges or I am interested in the entire region? So you need to represent which region is important and describe it. Maybe you just identify the okay the contour and say this is because you need to in fact identify the shape later. And the last one is object recognition, where you recognize the object. Of course, in license plate region, recognizing characters could be a part of this object recognition. That means how I recognize it to be C or A or K or whatever it is. So as I mentioned, these are the various chapters in the textbook R.C. Gonzalez, and you can also add few more blocks which as and when these new techniques come. And observe also there is a demarcation from this part to this part. That means enhancement, restoration, color image processing, wavelets, compression, morphological processing. Output will be image. Input is an image, output is also an image. So after compression, you will have a compressed image. After image restoration, you will have a restored image. You will have an enhanced image. Okay, after color image processing, you will have a color image or you may have a gray shade image. Anyway, they are all yielding you images. But these blocks, segmentation, representation, object recognition, outputs will not be an image. It will be actually some okay feature of an image that you are going to, or some attribute of an image that you are going to recognize. For example, here it will be some segment of an image. Here it will be either the shape. For example, it could be a circle or rectangle or whatever it is. So object recognition says, okay, the object is recognized or not. So the output here would be some attributes. So this is actually a block diagram, and I also had told you, and I think it's written here, every process need not be applied to an image. That means if I am just performing image denoising, I don't need to go for morphology or segmentation or any of these blocks, compression. My input is maybe a degraded or noisy image. My output is a denoised image. So I don't need all these blocks. If I am using license plate recognition, I am not interested in color of the license plate. I don't need color image processing. I may not use wavelets. I may not use any compression. Okay. I may use enhancement. I may use restoration. I may need morphological processing. I will need the definitely segmentation and then recognition. So some of these blocks are missing. Okay, so this is actually the steps. There are two ways of asking questions on this. One is the straightforward with neat block diagram explain the fundamental steps. Okay, normally I don't ask question directly like this. The question would be different. Okay, it would be you are required to recognize license plate region, license plate number of a vehicle entering into the campus. Suggest suitable block diagram that performs this operation and explain the need of each of this block. Okay, so this is exactly what you are supposed to do in the exams. That means you cannot directly write this block diagram. You should know what different blocks that are required. If it is face recognition, you should decide what all the blocks that are required. Do I need color processing? That means you should justify the blocks. So my suggestion to you is various in fact systems. So for example, license plate recognition system, hand gesture recognition system, face recognition system, and I'll list out another one or two more. Try to identify what are the blocks required. So one of them would be probably asked during your exams. So don't expect that you have to write this block diagram completely. You may have to fit this particular block steps for your requirement. And in the center here, you see a bigger area called knowledge base. So you may be wondering what is the need of this block in image processing. Okay. Uh, See, let us assume that I am working on maybe license plate recognition system only. Let me just take the same example. Now, what is the knowledge that I need to have about the license plate? Okay, that is very important. Every country has got its own standard of the license plate. So every country has got its own, in fact, uh, uh, okay, standard of having the license plate. For example, um, in India, you'll have something like KA and then some number like 06M, then four-digit number like 5974. In fact, this is my vehicle license plate number. So, but in other countries, it may not be same. So what you know is the first two alphabet will talk about the state. It can be KA, it can be DL for Delhi, it can be anything. For example, if it is Andhra Pradesh, it could be AP. If it's Tamil Nadu, it is TN. So the first two alphabets will be telling me about which state it belongs to. Okay, then 06, 05, 04, it belongs to the specific district RTO office. For example, Tumkur is 06. Bangalore, I think you have 01, 02, 3, 4, 5, and I think now they have also added some numbers. Okay, so similarly, each of this would tell me which okay district it belongs to or which RTO office it belongs to. Then followed by some digit like A, B, C, D, M because that is added now because the number of vehicles increased. Now I think if all the say 26 alphabets are over, they will repeat them like A, B, A, C, A, D like that. So the last four digits are number 5974 is a number. So whenever you are trying to recognize license plate region, license plate number of a vehicle, maybe in India, your knowledge base should have this. That means when I recognize the characters, the first two will be alphabets. Okay, for example, KA is an alphabet. It has two alphabets. So if while recognizing, if my recognition system because of some mistake, if it recognizes it as zero, I should discard that because definitely a zero cannot be there as a first two alphabets. I hope you have understood what I meant. Okay, so this type of knowledge will be stored. That means you already know the the requirement. For example, if I am trying to recognize I develop a character recognition system for Kannada characters. So my knowledge base should know all the Kannada characters and in fact, if I am trying to recognize handwritten Kannada characters, no, I should know all the variants of the characters that I write, because every one has got his own style of writing the characters. So my knowledge base should store this information so that it helps me in identifying the required in fact solution easily. That is what knowledge base does. Okay. So this is about the fundamental steps. I'll just break for a minute. If you have any specific questions, you can ask me now. Okay. So yeah, obviously, I assume that there is not much to really understand because it's straightforward. So let us go to the next um, topic: components of an image processing system. Now, assume that we know what are the various blocks that are used in image processing system. Now, I decided that I need to do a project on one of these applications that is listed. What are the components I need? Okay, so that is actually, this is for a general purpose processing system, but more or less this is what you need. Okay, the problem domain again would depend on the application that you are trying to do. Image sensors, as I already told you, you need to decide what sensors I have to use. For example, if I want to work on license plate region, my sensor could be a simple camera. It could be a still camera or it could be a video camera. If it is for X-ray, I have to use an X-ray imaging sensor. I cannot use the usual camera. I cannot use my mobile camera and capture X-ray of an image. I cannot do that. You know that. Suppose if I want to work on thermal images, that means I need to use a thermal camera. So depending on the wavelength that is required, there are different types of sensors. In fact, if you look at the first few pages of Gonzalez, he has given all the application areas of image processing. If I can read it out for you, it is having X-ray imaging, it is having ultraviolet band imaging, it is having visible and infrared band imaging, so on and so forth. There are many. If it is, I can also have microwave band imaging. There is what is known as radio band imaging. There is what is known as millimeter wave imaging. That means depending on the, for example, let me tell you what is this millimeter wave imaging. Uh, Actually, there is an area called concealed weapon detection. What people do is they will just get operated themselves and conceal the weapon inside their body and carry it. So such weapons that are being carried by person, if it has to be detected, you cannot use your usual imaging technique and capture it. It will not be visible. So for that, they actually use what is known as millimeter wave imaging, so that it will recognize uh, the concealed weapon inside the body. Okay, if you just Google, you will get lot of information about this. It's a very big area of research called concealed weapon detection. So the sensor is different there. If it is X-ray, the sensor is different. If it is ultraviolet, it is different. So depending on the requirement, you need to go for. If it is MRI, you have a different sensor. So sensors is decided by the problem domain. Then when I want to perform image processing, I need to have some specialized hardware. For example, your 8051 microcontroller that you studied in fourth semester cannot be used for image processing. You need to have a signal processing capability. That means at least it should perform a simple operation like convolution. Your microcontroller cannot do it so easily. So you may have to use a DSP processor. For example, now Raspberry Pi is effectively being used for many image processing technique, which will have this capability. So this specialized hardware would be in a position to perform operations like convolution. It can do filtering directly. It can perform any enhancement. So that means it is capable of doing these operations, because what is required here is images are of larger size. So memory is a very important requirement. Not only that, the processing speed has to be very high. So I may need a specialized image processing hardware to perform that. So that, for example, you remember when I showed you this ball bearing, in fact, sorting project, it was 100 images per second. So I need to process 100 images per second. So the hardware that I use should be very fast. That is why they actually used FPGA implementation there, so that it is very fast. So specialized processing hardware is required, and specialized software is also required. For example, MATLAB has this image processing toolbox. If I say im read, this is a special command that is available in image processing toolbox. So such softwares are required. Of course, MATLAB is one of them where image processing toolbox can be used. You can use OpenCV, which is also having a lot of image processing algorithms available. So these type of specialized softwares will help us in saving our time. For example, I don't need to spend time in writing code for reading an image itself. I'll just use a command im read, it reads for me. In the background, there is a lot of thing that is happening, but in the command will directly do the operation for me. So you need an image processing software. Then you may, in addition to the hardware, you may also need uh, just give me a minute. You may also need a computer also. Maybe you may have to display the data. You want to see what is happening. You want to debug. So I need some computer also. I may have to take hard copy of the data, so I need a device which can give me the hard copy. You want to display the data, so you need some specialized display devices. Why it is specialized display? Because one of the reason why I shifted from ECL 301 to ECL 302 your class is the display. I was not very happy with the display that you are getting in ECL 301, because if the image quality is not good, you will not appreciate what is really happening. So that is the reason why I shifted from 301 to 302. So the display in 302 is of better resolution or better quality compared to what you have in so what I want to convey is image displays are really very important. I need to, in fact, every finer detail has to be displayed clearly for me. So you need specialized image displays. And when I'm working with images, when I'm working with videos, I need to store the data, and you need a mass storage because huge amount of data. So I need to store it. So I need some mass storage devices, some hard disks which are capable of okay, storing a higher amount of data. Okay. And it would be good if this system is connected to the network, so that you can probably, okay, use the network for maybe communication. So these are the various components that are required. So whenever you are developing an image processing based system, you should first decide what camera, that means sensor I need to use, what hardware you want to use, whether you want to use a DSP processor, you want to use a Raspberry Pi processor, or you want to use some ARM controller, whatever you are interested in. So you need some software, whether you want to use MATLAB or you want to use OpenCV or Python code. It is all depending on your requirement. Then of course, some hard, that means the storage is also important. So you need to have the storage capability of the hardware that is used. So these are the various components of a general purpose image processing system, which are in general, but some of them could be very important. Okay, so that is about the various steps and components. Now let us try to understand how the image is formed. I have just summed it up in one single slide. Whenever I capture an image, what you see is there is some illumination or light that is falling on the scene, and the scene is going to reflect that. So I can say that the gray level that I capture is a function of two things. One is the illumination, other is the reflectance. That means what is the amount of light that falls on the scene and what is the amount of light that is reflected by the scene. So actually the product of these two, illumination at any coordinate xy multiplied by the reflectance from that particular point, okay, actually gives me the gray level, or sorry, the pixel value. Okay, so your f is a function of illumination and reflectance. Now all of you know that illumination can be controlled by us. That means I can increase the illumination by just increasing the power given to that source. Of course, um, illumination could go even up to infinity. That means it can be very high. Minimum is zero. That means there is no light that is falling on the scene. Reflectance, we take it to be in the range of 0 to 1. 0 means complete absorption, and 1 means complete reflection. Okay, depending on the object, this reflectance changes. Okay, of course, these are the theoretical bounds. I cannot have infinity. Similarly, I cannot have 0. But theoretically, illumination is from 0 to infinity, reflectance is from 0 to 1. Now the typical ranges, just to understand, on a clear sunny day, I think today in Tumkur it is a clear sunny day. Usually in summer that is how it is. Normally the illumination is about 90,000 lumens per meter square. This is normally a typical value. If it is a cloudy day, then around 10,000 lumens. On an evening full moon, it is only about zero point 0.1 lumens. Full moon day, I think objects are visible, but still the amount of illumination is very less, zero point 0.1 lumens. And when somebody builds a commercial office, usually the expected illumination is about 1000 lumens per meter square. So these are some typical values. And the reflectance, if it is a black velvet, the amount of reflectance is very less, 0.01. Stainless steel definitely reflects to some extent, so 0.65. That means what it means is 65% of the illuminated value gets reflected. And the white wall paint is about 80%. Silver plated metal is about 90%, and snow is about 93%. So what this tells me is, suppose in a commercial office, 1000 lumens per meter square is the illumination, and I am trying to capture an image of a stainless steel object. It is going to reflect by 0.65, which means that the value of f will be 1000 multiplied by 0.65. That's what it means. So that is okay. That is roughly the calculation. Suppose in the same scene, I also have a black velvet with the same commercial office 1000 lumens per meter square. That means some part is black, it only reflects 0.01%. That means it is 1000 into 0.01. So you can imagine what would be the minimum value, what would be the maximum value of this f that you are going to get. And this minimum to maximum is going to be discretized. So that's what we discuss in the next slide. So the at any coordinate x naught y naught, if I have a value equal to say f, that is I, it will have some minimum and some maximum value, as I already mentioned, depending on the object. Even though the illumination is same, reflectance may not be same from all part of the scene, so I may have some minimum value and maximum value. And this minimum value I'll get when the illumination is minimum and the reflectance is minimum. Maximum value it is when the illumination is maximum and the reflectance is maximum. In a commercial office, illumination I minimum and I maximum will be same. You know that because once I fix the light intensity, let's just assume that it is constant. The only change will be depending on the scene. It could be reflected less or more. So an example is given here with average office illumination. Um, you will have maybe an L minimum of 10 and L maximum of 1000 depending on if the in fact if the reflection is maximum. That's what it means. And this range minimum gray value to the maximum value, this range they call it as the grayscale. Okay, and normally they will just shift it to the interval between 0 to L minus 1 where 0 is black and L minus 1 is white. Okay, so this is what in fact uh, happens when you capture images by using some illumination. Okay, I think this topic we will take it up in the next class, how I can sample and quantize images. Till now, if there is any clarification from your side, please let me know. Okay, meanwhile I'll also share you uh, on the chat window a link where you need to give your attendance.